So we have what we call this hinge theorem, right? I'm not super concerned that you remember what the hinge theorem is, more besides the fact that you might see it in a problem, say use the hinge theorem, right? Just knowing that this is kind of where it's at. So the idea with this is that I have two triangles with two pairs of congruent sides, right? So okay, I have those two pairs of congruent sides, but these angles, so angle A, the included angle, and angle X are not congruent, all right? So the idea here is that if the measure of angle A is greater than the measure of angle X, right, that tells me something about the sides that are opposite those angles, right? So opposite of A is BC, opposite of X is YZ. So in a very similar kind of way from what we looked at on Thursday, because angle A is bigger, that means that that side that's opposite is going to be greater than the other side, right? So BC is greater than YZ, right? So it's longer. Okay. It also works backwards, right? So if you know something about the side length, so if you know that BC is greater than YZ, then A has to be greater than X, right? So it's a very similar kind of thing to Thursday, except for now we're just looking at two triangles.
All these little alligator signs really getting me here.
Okay.
So look at a couple of examples. So this first one wants to know what are the range and values of X, right? So this is kind of like what we talked about with the range and values for making a triangle on Thursday, right? So what they're doing is they're comparing this 60-degree angle, which kind of corresponds to that 15, right? And this angle that's 5x minus 20, that is corresponding to that 10, right? So what I'm going to think about is 5x minus 20 going to be greater than or less than 60? So why the less than? Because 10 is less than 15, right? So because it's across from the smaller side, I know that it's less than the other angle. So I just need to solve this inequality, right? Don't get freaked out about inequalities. We're going to solve them the same way we would an equation, right? So add 20, add 20. So 5x is less than 80. Divide by 5. So x has to be less than 16. Right? So now that's kind of that upper bound, right? I need to think about the lower bound. So what's the smallest thing that angle could get really close to but never hit? 0, right? I have to be greater than 0 to have an angle. So I know that 5x minus 20 also has to be greater than 0. Right? So now I can solve that one, right? Same steps. So 5x is greater than 20. X is greater than 4. Right? So now these two things are my answer, right? X has to be between 4 and 16. Okay? So you might have other examples where, say that the X was part of the bigger angle, right? It was bigger than the other one. What's the biggest angle that I could have? What? Say it. 180, right? 180 is the biggest angle I could get to really close to. So if you're looking at, it has to be less than something, right? It has to be less than 180. So that might come up on a lesson quiz. So think about that. Those are your two bounds for angle measures, right? 0 to 180. Okay. Why won't this one stay up there? Okay. Last thing is they'll say write inequalities between side lengths, basically. So what it's saying is, what's the relationship between the length of AC, so the length of that red side, to the length of FE, right? So here I'm just looking at angle measures, right? So B is 55, D is 65, so that means that EF has to be what AC? Greater than, right? Because D is the larger angle, so that side has to be bigger.